You walk into like a modern conference room or a high-end sports bar, and you're just surrounded by these flawless, giant 4K screens. And naturally, you'd assume the drywall behind them is just packed with thick, specialized video cables, these giant pythons of copper wire.
Right, yeah, because we tend to think that massive visual data requires massive, dedicated plumbing. But the industry has fundamentally shifted away from that physical mindset.
Which brings us to our mission for this deep dive. We're looking at a detailed product spec sheet from HDTV Supply for this piece of commercial tech, the Intelix IPEX5001-WP-W 5000 series wallplate. We're going to decode the heavy AV jargon here to show you exactly how massive 4K video setups are secretly routed through the walls around you, using literally nothing but standard 1 gigabit office network infrastructure.
It's wild. It completely changes the architecture of how we handle media in these commercial spaces.
Okay, but just looking at the raw math here, I mean, it feels like this shouldn't work. We are talking about pushing uncompressed 4K video at 60 hertz, complete with HDR10 and 8-bit color. How does all of that, millions of color shades and dynamic lighting data fit onto an everyday category cable and travel up to 100 meters?
Well, uncompressed, it wouldn't. That signal it's a massive fire hose that would instantly crush a standard 1 gigabit network. The solution really lies in the encoding mechanism, specifically JPEG 2000.
Right.
Instead of forcing a constant stream of full-frame data down the pipe, it uses a variable data rate. It analyzes the video frame by frame. So if the background of a scene isn't moving, the encoder doesn't waste bandwidth retransmitting those pixels. It only sends the data for the pixels that actually change.
Oh, okay. So it's almost like packing a vacuum-sealed travel bag. The encoder sucks all the empty air out of that massive 4K video signal on the fly, shrinking it down to fit through a standard network carry-on size, and then perfectly inflates it again when it hits the display.
Yeah, that is the exact mechanism. By only transmitting the changing visual data, the stream averages around 250 megabits per second, with the headroom to peak at 850 megabits during really complex, fast-moving scenes.
Wait, 850 megabits per second is still huge, though. If someone is presenting a high frame rate video, wouldn't that massive spike risk lagging the rest of the office's network traffic?
Oh, absolutely. I mean, on a flat network, it would. That's why these AV over IP systems are typically isolated on their own virtual LANs managed by the network switch. The IT infrastructure essentially acts as a traffic controller.
Right, keeping the heavy video data in its own lane so it doesn't collide with everyday office traffic.
Exactly.
So the network handles the heavy lifting behind the scenes. But think about the user actually standing in that conference room. They just want to plug in and present, right? How does this wall plate handle the physical interaction?
Well, the hardware is designed to minimize user friction. So for power, it utilizes standard PoE, or power over Ethernet, from the network switch in the server room. That completely eliminates the need for a local wall outlet.
Wow, that's incredibly convenient.
Yeah, and for the display, it features automatic switching between its HDMI and VGA inputs based on a simple last-in, first-out protocol.
But there is a crucial technical caveat here from the specs. That auto switch requires a physical connection to engage. You can't just, wake up a sleeping laptop that's already plugged in and expect the room's screen to switch over to you. You actually have to physically plug the cable into the wall plate.
Right, because it relies on a hardware-level trigger
Right.
rather than software polling. The wall plate needs to detect the physical voltage change of the cable seating into the port to know it's time to take over the screen.
Which sounds a bit annoying at first, but it totally prevents that classic nightmare scenario where a random laptop wakes up in the background to install an OS update and suddenly hijacks the presentation screen.
Exactly. It keeps control predictable in a shared space. And, it's managing a lot more than just the screen.
Yes, looking at the connections, it's embedding and de-embedding analog audio into the digital stream. It's passing through RS-232 commands, which are the serial signals that tell the room's control systems to actually turn the projector on or drop the screen. It essentially turns a simple wall plug into a virtual Swiss Army knife for system integrators.
It really does. It also extends USB 2.0 up to 12 megabits per second. And by default, those USB signals and the built-in infrared receiver follow the exact same network path as the video. But they don't have to. The specs note they can be independently free-routed via an API.
Wait, really? Since an API is just a software interface telling the hardware what to do, that means an integrator can command the system to split the signals.
Yeah, Exactly.
So the video packets can be sent to a projector in the room, while the USB data packets are simultaneously routed to a completely different computer sitting in a server rack down the hall.
Right. The physical cables no longer dictate where the signal goes. You're no longer pulling dedicated wires for specific functions. You're just providing a flexible data pipeline.
Wow. We've really unpacked how network-based devices like this Intelix Wallplate are rendering traditional fixed matrix switchers totally obsolete by routing everything over IP.
It's a massive leap forward.
It is, which leaves you with this to chew on. If
Yeah.
we can already route flawless 4K video, controlled data, USB signals, and electrical power all through a single standard Ethernet connection and API commands, how long until the concept of a dedicated video cable completely disappears from our homes and offices? Those copper pythons might be going extinct a lot sooner than we think.